Hello, let's continue working with the project, and we're now about to start iteration number 8, which focus on calculating the score. Um, so we follow the same steps. So iteration 8, calculate the score. And we'll go with the app development process, the 3 steps problem formulation. And in the problem formulation, we'll talk about the scope. So the scope here is to calculate the score, and most cases you know what the formula is for calculating the score, and there are multiple formulas and multiple ways to think about the score for this particular application. The one I'm gonna use is simple. The number of correct answers, or count of correct answers divided by maximum number of turns, and maybe multiply that by 100 so we can get a percentage. So 100 multiplied by the number of correct answers divided by the maximum number of turns. Now this is a very simple way of thinking about the score that takes into consideration only whether the answer is correct or not. You can think of more complex or multi-factor way to calculate the score, like incorporating the time, how long it took to find an answer, or to find all answers. You can incorporate past history, so you can bring in you can put levels of difficulty. So maybe some notes can be easy notes that maybe have a multiplier of 1 or less than 1. Maybe some notes can be more difficult, so they will have higher multiplier. So you can make an easy or difficult manner of calculating the score, but all of these will end up with one mathematical formula, as you can see in front of you here, and that mathematical formula will then be used to calculate one number, and that number will represent the score. So how do we test this? Testing scenario 1, we want to test for mathematical accuracy, that when the user answer all answers correct, we want to see that the score is 100, because if the number of correct answers is the same as the number of turns, this division will be 1, and 1 multiplied by 100, that's 100. So for testing scenario 1, answer correctly on all turns and observe that the score is 100. Then another scenario is perhaps the other extreme. Answer incorrectly and observe that the score is 0. And then there's another one in the middle. So if you have 3 turns, then you actually want to do answer 1 correct, and then the score will be 33, then answer 2 correct, and the score will be 66. So answer 1 correct and observe the score 33. And then the last testing scenario in this case, answer 2 correct and observe the score 66. So we answered and we got all of them. So what happens if you have a very large number of possibilities? You can program the testing. So you can put all the possibilities in a database or a file, and then in your testing you just run the test automatically and have the application pull those possibilities and test against them. You can also not test all of them. You can just pick a group of a sample and test for that sample, and then hope that you would have covered all different cases. So in the next step is the solution formulation, and we're thinking about the model which give us information about the data. So we have 2 data elements. We have a score, and the score is a number You can decide whether you want this number to be decimal or non-decimal. I'm gonna go with non-decimal here for simplicity, so I'm gonna say it's non-decimal, and then I will use int, which is the data type that represent integers or non-decimal numbers. The maximum number of turns, we already have it, but the number of correct answers, that's new, so we will need to add that. It's also non-decimal, and so we will use int to represent that number. How about the display, the view? We'll add the score to the alert at the end of the game. And this is similar to the mockup that we had. In the mockup, the score was included in the alert. So when the game is over, it tells you what your score was. So we'll keep that. And then finally the controller. And the controller is interested in calculating. So when are we going to calculate the score? As we mentioned before, in the controller, we are thinking about the when and then the how. So when is it gonna happen, and then how it will be done. So when would the score be calculated? So should we have different phases of the game? So should we calculate the score at the start of the game? Should we calculate the score during the game? Or should we calculate the score at the end of the game? And you are correct that the score is actually you may calculate the score during the game. You can have like a running live score. Every time the user makes an answer, you can display a running score, or you can say I'm gonna give the score just at the end. In my implementation here, I'm gonna go with the end, but that's having a running score or a live score is something that you can add as an enhancement for your own application. So to calculate the score, so we'll say that the score will be calculated in the end game function, because that's when the game ends. But to calculate the score, you need to keep track of how many correct answers. So we will need to add the number of correct answers and increment that. So when would we increment the number of correct answers? So every time the user makes an answer, we go to the function called the CheckAnswer, and in that function we make a determination whether the user selection was correct, and in this case we display the correct answer text and image, or if it was incorrect, and then we display the incorrect answer and image. So if we are already determining if the answer is correct or not, the best place to increment the number of correct answers is right there. So increment the number of correct answers when the in the CheckAnswer function, when the answer is determined to be correct. So the last piece is the implementation. So in the implementation here, we need to add a variable to hold the score. This variable here is like a memory location so that you keep track of the score. And we need another one, add a variable for the number of correct answers. Then we need to change or increment the number of correct answers in the CheckAnswer, and then calculate the score in the end game, and then update the alert dialog to include the value of the score, and then finally test and commit. So let's go ahead and do that. So we go to our application. Whenever you ask it to create a variable, you want to ask yourself, should I create the variable inside a function, or should I create the variable with the class scope? The scope determines which function has access to the variable and how long that variable or that data stays in memory. If you give it the class scope, it's available everywhere, which is the case that we want to do for the number of correct answer and the score. Why? Because the number of correct answer will be incremented here in the check answer, but the score will be calculated here in end game. So both the end game block or function and the check answer function, both of them need to have access to the score and the correct answer, so we'll increment them in here. So we'll say variable, and we use the var, not let, because the data will change. So we say score, and then we'll give it the type int, and you can decide to initialize it or to suppress the initialization. So let's go ahead and initialize it here. The same for correct answer. So we can call it number of correct answer, and that also is int, and we initialize it to 0. Right? So we need to go to the check answer function, and inside that if statement, in the check answer function, we retrieve the text from the button that the user clicked, and we append .mp3 to it and compare it to the current node, which is the random node that's being played. If the comparison returns true, the true block of the if statement, which is the conditional statement, will be executed, and the else will be skipped. If that comparison returns false, meaning that they do not match, the true block will be skipped and the else block will be executed. Or in other words, the correct answer is inside the true block and the incorrect in the else. This is because I set the condition to test for the true. So here I need to increment the number of correct answers. So every time you determine that an answer is correct, you need to increment the number of correct answers. So you can say number of correct answers equal number of correct answers plus 1. There is a shorthand for this. You can do something like this, number of correct answers, and instead of saying equal and then repeat the same variable again, then plus, you can eliminate that same variable altogether and leave it equal plus, like that. If you do number of correct answers equal plus, I think it need to be plus equal. Yep. Plus equal. When you say number of correct answers plus equal, that shorthand means number of correct answers equal number of correct answers plus 1. So you're incrementing by 1. If this is confusing you, you can just do the other one, number of correct answers equal number of correct answers plus 1. Either one of them work. Both, but don't do both, because if you do both, you're incrementing by 2. Which is also, maybe you want your score to be enlarged, so you give it a large number. Sometimes you can multiply by a large factor so that the scores are in the 10,000s instead of the single digits or in the hundreds. Then you come to the end game. So in the end game, we want to calculate the score, and then you want to update or do the alert. So calculating the score will basically say score equal number of correct answer multiplied by 100 divided by the maximum number of turns. Then you have the message, thank you for playing the game. We want to update that message and include the score in it. You can incorporate the score right inside the text, but that will make that initialization statement a bit complex. So I would prefer to create a variable to calculate the message and add the score to it, then just use that variable over here. So I can say here, let alert message. I'm going to give it the name alert message, and then I will copy that message that I have and put it in here. And instead, now in place of the message, instead of putting the text as a string, I'll just put alert message. So I replaced the hard-coded value of the message inside the initializer call with a variable. What I'm basically saying, go to this memory location named alert message and retrieve the actual text from there. So now let's construct the message. You can use the localized string with format if you would like. You can also inject the score. So you can say thank you for playing the game. Your score is, and then you can do the shorthand injection of the value by using the slash and the parentheses and type the score in here. You can leave the score like that. If you want to add a percentage, you can just add a percentage here, and that will give you the percentage. If you don't want the percentage, you can leave the score as is. So let's try. So we started the game. Now we'll try to intentionally do all answers correct. So all answers correct, so I should expect a score of 100. So your score is 100, here it is here. And then cancel. I'm not really happy with the word cancel, because I'm not really canceling, I'm just acknowledging. So I'll just, I want to change cancel to OK. So the cancel was the text on the alert action. So I'll do that and say OK here. Then I'll have to run again. So start again. So all correct answers, and that gives me 100. So let's play again and just have one correct answer. So here is the one correct answer, and then we want the others to be wrong. So I expect the answer now to be 33. So it is coming, your score is 133. It should be only 33, not 100. So what's happening? Let me try another one. So I'll make 2 correct answers and 1 incorrect answer. So I should get 66. I'm getting 200. It looks like the score is adding to the previous score. Every time you play the game, it adds to the previous one. Because I know what's happening, we never reset the score. Every time you start a new game, you have to reset the score. Like we did with the turn counter. Every time a new game starts, you reset the counter. So we need to reset the score. We also need to reset the number of games played. So we created a function called reset game, and so far the reset game only resets the counter of how many of the number of turns. I also need to reset the score and reset the number of correct answers. So let's do that. Number of correct answers equals 0, and the score equal 0. So let's try now. And the score and the number of correct answers are reset at the game level, not at the turn level. So remember, we had a reset game and a reset turn. So far, the reset turn only resets the images of the feedback mechanism. So we answer So that should give us 100. Then let's do another one with just one answer. And then the second one. So I should get 33 for this one. So let's see. Alright, so your score is 33. So everything is resetting correctly. So let's do the last one. Have 2 correct. So that should give me 66. Alright, I think I have another one which is the 0, like answer incorrectly, all of them. And I should get a score of 0. And here is a score of 0. So that gives us everything. So we finished all the things related to this iteration. So we now commit and push, and in the next iteration we work on the stats. So now that we're able to calculate the score, we can build the statistics for the game. So we'll say here calculated the score and completed iteration 8. Push and commit. So in the next video we'll start with iteration 9.